Hi, Jose. How are you? Sorry, my dog is going crazy because the thunder started happening. Quit. I heard you went to pick up your kit today. Yeah, I saw they have some on the rack. I don't know. There should be a lot more in the boxes that I ordered. So I talked to Abraham today. I saw that he pulled some of those out from the boxes. So yeah, there should be a lot more kits. We had ordered quite a few, so well, I'm glad you picked up one. So you can start working on it today. We'll wait a few more minutes. Okay, yeah, no problem. As long as you have it done by the end of the week. Hi, everybody. How are you doing? We'll start in a few minutes. It started raining here in Moreno Valley. Stop. We'll begin in a few minutes. So check out the lab while we wait. And then take out your Arduino kit. I'll touch on where we left off yesterday, and then we'll talk about what we need to do today. We're only going to do one exercise today, and then we'll do one more tomorrow. So I know some of you are still trying to catch up. So I'll give you time to do that. Okay, so while we wait another minute, check out the lab, and then we're also going to revisit the exercise D from the assignment, okay?
And then the other person is.
Hi, Ryan. Okay. So if you haven't done so, look at Canvas and look at the lab, and then we're gonna do the first exercise today, but I want to walk you through it and talk about it. Okay, so welcome back. Day 3 of CIS833A. This is Arduino for beginners. So, Rogelio, did you have any questions?
No, sorry.
That's okay, no problem. Yeah, anytime anyone have any question, please unmute and ask. Um, when I'm in screen share, sometime chat can be a little touchy, but I will check the chat. So we left off yesterday with this exercise here, which is when we did the happy birthday song with the Arduino um, part B. Let me go into screen share. Forgot to do that. So Hannah had gone on to my office hours yesterday and she pointed out something. And as I mentioned to you that yesterday when I was hooking up my LED, I think something was funky. So I fixed it and I re-uploaded the document. So the document that was re-uploaded today has the latest diagram. So if you're running into issues with exercise D, which is the last exercise we did yesterday, you will find my new drawn diagram and a new picture that's added. So that way it will help you. So one of the things that I saw and Hannah saw this too was that when you plug in the ground in the circuit that was previously added to the document, it's not going to make any sound and it's not going to blink the light. So what I want to show you is, so I fixed the problem. You simply just remove the ground cable from the ground connection from the breadboard to the Arduino. It should work. Okay. So Kevin asked yesterday, what is it supposed to be doing? Well, the first thing, sorry, my camera is not cooperating. Let me see if I have it. Okay, so the first thing you should see is when you plug it in and you upload your code, it's going to turn on all your LED. Then when you press the button, it's supposed to blink the LED. I don't know if you can see it. And then it's supposed to have the happy birthday song through the buzzer or the PSO. So your LED is supposed to randomly changing right throughout. And so if we press it again, it should be going. And so as you can see, it should be blinking back and forth. It's kind of bright. Okay. So that is supposed to be how you're supposed to hook it up together. So what I did, let me unplug it because it's going to become very annoying for you. Um, what I did was I had changed up the diagram. And so I simply just removed the ground cable that goes from ground to the actual breadboard. And then one of the things that I wanted to point out to you when you hook this up is that remember that all of these needs to be in specific path. So as long as you keep it in the same path but not overlapping another path except for a few things, then you're okay. So the black cables here are going to be for the ground. And so that's why it's going to go to the negative because as you know, it's going to flow from positive to negative. Your positive on the buzzer is going to go to the pin, and then on the LED, the longer leg is gonna be it's gonna crisscross. So what you should do is you should make it like with the gap so that way you can cross it over so it's not overlapping to the other leg. Otherwise your LED is not gonna light up. And then the other leg, you just hook up the cable and those are gonna go into the pin that's gonna be positive. The other diagram that was included before has it connected to 5 volt, which doesn't work. And I mentioned in the last session that you need to move it over to 3.3 volt. So really, LED doesn't require a lot of power, so are these guys. So what happens is you're only going to need about 3 volts to really drive all of these components. Now, when you plug in the 5 volt, automatically your Arduino would shut off. It's because it's too high of a power and they put in a safety so that way it turns off. So what you need to do is you need to plug the button is gonna go into the 3.3 volt. And in the program, we had stated that when this button is on, which is gonna be 1, it says that it's going to be equal to 1. At that state, it's going to activate, it's going to loop through, and it's going to randomize the light, and it's going to play the buzzer. And that's what should be happening. And I think Kevin asked that question at the end, and I didn't get a chance to answer it last time. So I wanted to address that so that way you know what the output of it would be when you created this. I know some of you already submitted it, but as you're working on it, so if it's not blinking, the LED, or if it's not sounding, um, there are 2 areas in all systems that you usually go through when you troubleshoot. Number 1, you need to really check your hardware connection. So you need to really look at your electrical components, how it should be set up. Number 2, then you need to look at your code, right? Is the syntax correct? Is everything is going to be, is it everything that you need? There is the pitches.h file included in your IDE. So this one we had to copy and paste all the notes over. Otherwise, you're going to get an error saying that, oh, you didn't define the note. So, and we got this by following the instructions, obtaining that from the library for the Arduino, or if you want to, you can also find this particular file online, but it's already built into your IDE library. Okay. So some of the things that we need to make sure that we look for. So if it's throwing any kind of syntax error, it will tell you like it cannot find this for this particular line and so on. And so that's how you would be able to troubleshoot it. Okay, so check your connection and then check your code. And then when you upload it, you're gonna wait for all the LED to turn on, press the button, it should be blinking back and forth, and then it should sound the happy birthday song. Okay, and with that, you would know how to put together a circuit that would do, it will make sound and it will also blink. Any question regarding assignment exercise D? So one of the things that I wanted to show you, I think one of the student had mentioned this earlier on, is Tinkercad has the option for you to go in, and I use Tinkercad to draw. Another option that you can use. There are a few websites, but Fritzing is another one. It used to be free, but now I think they charge a few francs or euros. Um, so you can use Fritzing. A lot of people in the community they use Fritzing, but you can also use Tinkercad. And Tinkercad is not just for electronics. Some of you probably use Tinkercad to learn AutoCAD, Autodesk, design, etc. But Tinkercad has a wide variety of things. So if you select this, you can see that you can, on the code side, it's a little bit different than what we would see in C, that it's really a block of code. So you would then drag and drop based on your diagram. It does a really good job at simulation. So you can draw it directly or you can have a built-in one. So it has a wide variety of circuits that you can just drop in and then add components to it. So for if you're teaching someone that at an earlier age group, right, like elementary school or middle school, this would probably be a good option for them to start before they start tinkering with some of the components. So here, as you can see, you can look at so this is the CR, this is your regular computer battery. And when I teach circuit to little kids, I usually start with a piece of paper and I have them tape the battery, and then I would have use copper tape or wire to hook it up. So That way they can understand what a circuit would be, how we can use things to turn the light on and off, like at home, um, and so on. So you can start with something very simple, and then you can go into some of the other areas. And so they do a good job with having a lot of different components. And so as you can see, you can search for LED, um, or you can just, find Arduino board like this one. Some already have connections, and then with that it will simulate the code that will go according to that. So this is a good way to use it without having the actual hardware. And then after that you can move over to the hardware side and be able to do that. Okay, since this class is very short, I don't really have a lot of time to really expand on this. So I go directly into the kit, and so that way you will have more hands-on physically with the components, and then you can also practice if you like using this. Okay, so this is a good way to simulate things if you don't have a kit. All right, any question? Okay, so this this week, for today, this is day 3. We are gonna work on a few things. Actually, just one exercise today, but I want to touch on Photocell. Um, and in the book that you have included with the Arduino kit that you received from iMake Innovation Center, there is a Theremin exercise within that. So you can use that, or you can use the document that I provided for you. So sometime you would see that this is called photocell or photoresistor. This is used to detect light. You often see electronic components like security light, or different type of electronic equipment that would require light sensor, that would use something like this. Toys, nightlight, auto dim light, stuff like that. You would see this type of resistor being used. So photocells are sensors that mainly are they are resistors that is used to detect light. And it's the reason why that a lot of companies use this is because it's very inexpensive. So what I did was, so I bought this. I don't know if you can see it. And you can buy a pack of them for very cheap, like $5 to $7. That's through Amazon. And if you want to wait a little bit, you can order it from other website that will be a lot cheaper as well. So for a pack like this, you can build many circuits, or you can expand on your circuit and you can use the photo cell. So when you look at the photo cell, they look exactly like the picture, but I'm gonna open one so you can see. It's gonna have 2 prongs, and they are basically the bottom is exactly the same length, and at the top you would see like a little wiggly line. Okay, and it's like an oval top, and it's very small. So as you look at the measurement, it's gonna be like about the size of a quarter or slightly longer than it. So in the industry, they sometimes can be called CDS cell because it's made by cadmium sulfide, and or sometimes people would call them LDR. So when you're looking at project and like on the hub or on the web, you often see projects that with the LDR name. So that means that they're using the photocell or the CDS. Okay, and LDR simply is a light dependent resistors or photoresistors. Okay, photocell or photoresistors. So that's what they're called. And like other resistor, there's resistance that's already been incorporated with this type of resistor. And it's going to use the pull down to really decrease. So we can also, in some circuit, you will also need to add additional resistor to really pull the current down to a very small amount. And that's what you need to be incorporating in a lot of the circuit. So that way it needs to be fixed to a certain kilo ohms. So that way it would work. Okay. So what I did was I included the chart so you can have a general realistic idea of how light is sensed. So when you're looking at a dim hallway, and the way that we would measure light is based on ambient light, and that is usually, if you read all the way the history of this, is because they measure it based on candlelight. So that will be a lux. Okay, so when you're looking at the dim hallway, that would be 0.1 lux, and the resistance for that would be 600,000 or 600 k ohm. And so what we want is, if you're looking at, if it needs to be sensing the light in the dim hallway, that's where, that's what that's the level of resistance that you need. If you go outside and it's a full moonlit night, that will be 1 lux. Okay, it's hard for us because we have a lot of interference with the light because of city lights, street lights, house lights, and so on. But in the way that we would measure full moonlit night, right, that will be not interfering with other light that's being shining around it. So that will be 1 lux, and the resistance for that, you would see that will be less. I have a question in the chat, so okay. Alex said that you don't have a photocell. Okay. So I'm gonna address this with iMake Innovation Center. Um, yeah, check in your it's taped to the Arduino box. David said, I found it on a bag that's taped to the Arduino box. Okay. Yeah, you check your boxes or inside your box. I made it clear to them that I need a photocell on the list. So if you miss one, they have extras at the iMake Innovation Center. Um, I know some of you live kind of far, so okay. If you don't have one, let me know at the end and then I'll work out something with you. Okay? So check your boxes or your kit. All right, so in the dark room, we would have 10 lux. So when you're looking at, like, those dawn to, I don't know, those light sensor that they use for home, or one of those adapter that you plug your light bulb in and then it automatically turns on your house light when it gets a little darker. So that means that it has some type of sensor, most likely your photocell sensor, that's being incorporated. And all that is going to be the resistance. They use a certain type of resistor. So if it turns on sooner before it gets really dark, is that you would have something that would be higher in resistance. But if it turns on really late when it completely pitch dark, then you would have a lower resistance, as you can see, right? Based on the chart. So in the dark room, let's say if your house goes dark and then the light turns on, that means that they're using approximately 10K ohm resistance, right? So combining with the resistor and the LDR, it needs to be a total of 20K ohm. Okay, so when you put together the circuit, consider that the total amount needs to be a certain K ohm. And then the voltage across, that should be 2.5. So it's pretty low volts in general. We would see that. Okay, Yeah, please check both of your kits. Thank you, Kevin. They don't tape it because I think different people put together the kits at the center. So um so in the for the dark room we only need about 2.5 volts. So when you look at that, if you take a look at like the watch battery, if you take two of those and you hook them up together, that should be enough to really drive right that circuit, which is 2.5 volts. But for like something like today, like overcast day or a brighter room, like with lights that's lit, you would see that's 100 lux. And so you, in order to sense that, you would have to have a higher voltage. So as you can see, it would be closer to 5 volts versus something that would be darker, right? To sense. Okay. So here it gives you a general idea of how you can compare. Any question with this? What does a photocell look like again? So if you look at the document on the assignment, it looks like this. And it looks, if you look at my camera, it looks like this. Okay. So it has two legs and the top is kind of flat. It's oval and it has a wiggly line on it. It looks like a little electrical line on it. And they don't come with the normal kit that you would get. This is usually, you know, something that you have to get on the side. So when you're buying an Arduino kit from online, rarely even on the advanced kit, you won't see the photocell within it, or the photoresistor. So it should look like this. Okay, any other questions? Okay, so I also included a link to Adafruit, and Adafruit does a good job in explaining this a little bit further. So if you wanted to read about it a little bit further, it goes into the electrical side a little bit more. So I wanted to give you a general idea of what, you know, what we're doing, right? We are using the photocell and we're going to incorporate that to make a theremin. And for the theremin, um, it's really a like a an instrument that makes like spooky, weird, whistly sound. Sometimes you see this being used for like Halloween toy or Halloween decoration, but they also use it on Star Trek, for some of the sound on some of the earlier TV shows. Okay, so we're gonna make like a musical instrument that makes like a whistly wooey sound. And so why are we doing that? Really is when you're covering it, right? You can code it when you cover it. That means it's dark. Then it's not gonna, you know, it can make the sound. And when you remove your hand or when you know shine the light on it, it stops the sound. So, or we can go the other way. So it's really depends on how you want to use it. And so extended to that table, you can have an idea of, you know, in your living room, how much light that would be, and so on. And this is just a set of example. It's not exact. Question? Okay. So a little bit more on Lux. Um, Here, this is just a unit for measuring like how light things would be or luminous things are. And so that will be your luminous flux per unit. And it is really a lumen per square meter. So in photometry, it's used to measure intensity and how we perceive light. And so that means that it would hit the and passes through the surface for our eyes to really detect it. So because lights travel as waves, right? And so it needs to hit the surface before it reaches your eyes. And this is in analog base. Um, so and it goes and it talks about your watt per square meter and how the power of that would be in wavelength weighted according to the function. And now in the resistance, as we mentioned before, we need to be in this range. Okay, so for very bright, then we're gonna go with 10,000 kilo ohm. For dark, it's just gonna be 200 kilo ohm. Okay, so it has to be within this range for the resistance. For sensitivity, um, now in with the lights and the spectrum, what you have is for the CDS, it's gonna respond to light between violet and orange. So as we would see this, and it would be useful also to test for us because for our household lights, even though it's close to natural light, it will be within this range. Okay. And then it's going to peak about in the area of green on the color spectrum of light. So if you need to detect something on the higher range, right, consider that these cells has limitation. Okay. So how do you supply the power? We generally use the Arduino to supply the power, and we're going to need about 5 volts. So from what I hear from the students, they were taped. Some were taped in the Arduino box. It's in the bag, and then if they forgot, they might have taped it in the Canna kit, which is the Raspberry Pi box. So if you check your Arduino box and you don't have it, then you need to look at the Canna kit if you have it. Okay, so you're gonna look for something that has the 2 leg with the flat top, just like the picture in the document. Yeah, so Alex said that she found it in the Raspberry Pi kit, which is the yellow box. The yellow with the blue edge. This one. Okay. So when they gave it to me, they haven't put it together yet. So I don't know exactly what is what. I just, the components that I have, I usually give them a list of what I want to use. So the Canna kit is this box. Okay. And then if you didn't find it in the Arduino kit. Okay, let me know if you still haven't been able to find it. Okay, so for the power supply, you can have it up to 100 volts, right? So you don't really need to have a lot of power for it. And this is why it's also chosen for toys and things, because that way you can use small battery with it. Okay, and for Arduino can be powered with the 9-volt battery or, a small power bank, like I said. And we generally power Arduino with our computer through the USB. So when it's dark, the sensor looks like a large resistor that would go up to 10 mega ohms. And as the light increases, the resistance goes down. That's why it's using the pull up. So that way it would just give enough power for the resistance that it needs. So it's flexible, so it's range based versus some of the actual resistor that would be rated for a certain kilo ohm or certain ohms. And photocells are very common, and sometimes most of the time that they would be implemented for light detection, but it's not. Keep in mind that it's not sensitive to all light, like what we said. So when on the higher spectrum, when you see it with the green range, you might not be able to use it to detect such spectrum. Okay. So for the light that's between red and green, okay, that will be sensitive, but beyond green, that you when it goes more into blue, you might have a harder time. Okay, so here it talks about blue is not going to be triggered, but it will be triggered about yellow and green, so before the green. Okay, so for this lab, you are going to need Arduino, USB cable. You're going to need a breadboard. You're going to need a photocell. So if you need a reference, that's also another picture. You are going to need a buzzer or a piezo. You can use the larger or the smaller one. I know most of you have the large one with your kit. And then you are going to need a 10K ohm resistor, just one. You're going to need a few jumper wires, male to male. And then you can use jumper wire for the instead of the preform. So Kevin asked for the resistor, how come we are installing it on the grounded side this time while the RGB LED and the binary dice example we install on the power side? So on this one, we need to pull it down, Kevin, because if we going back to what we have, the photocell itself is a resistor. It already have the resistance. So we wanted to make sure that it needs to be in a certain, it needs to give you the certain amount of resistance. On the LED, the LED doesn't come equipped with resistance, so we don't need to make the adjustment with that. So additional resistor on this particular project is really used to be grounding it for so that way we can pull it down, and then itself will have a pull up. Okay. So it's a little different than the other one. And also, like on the LED is limited to a certain amount of power. So we have to regulate the power that's flowing onto the positive side as it's going to go through, it's going to exit on the other side, which is the negative side, right? It's going to travel from positive to negative. So on the Arduino, you send power from the Arduino to the positive leg and through the wire, and then it's gonna go to the negative side. So and on this one, since we already have the resistance, it needs now, because lights is it's analog, it's not constant, it's not 0 or 1, right? It's gonna be varied throughout as it is a wave. So what you would see is that you would need to have the adjustment on both sides. Okay, resistance on both sides. All right. Where was I? Okay, so we talked about the components, and then we can use the preform jumper wire and so on. So any question before we start? I'm going to give you a lot of time to do it today, and I'm going to do it with you. So, and then if you want to, after you finish, you can work on the other one, or we can work on the other one tomorrow. So the first week I'm going to keep, just making sure that everybody is going to be able to achieve all the tasks. I don't want to give you too much to do. So, all right. No questions? Okay. So the next part, we are going to connect the photocell, okay? And they are basically your resistors. So going back to Kevin's questions, that photocells are already resistors. They are not polarized compared to lights. They are polarized. So they are non-polarized. That means that you can connect them either way. Remember the LED, there's a short leg and a long leg. And also when you're looking at the piezo or the buzzer, it's the same way. So these photocells, the leg should be exactly the same length. Just like your regular resistor, you can connect them either way. Okay. All right. So let's spend a little bit of time and putting together our circuit. And I'm going to give you time to do that right now. And then I'll hook up mine. After you put together your circuit, you can open your IDE, put in your code, and then make sure that you configure your Arduino port connection and all of that good stuff. Okay, and then upload your code. So the way that you test this one is to put your hand over the photocell or your circuit close to it, right? Like if you give it darkness, cover it. You don't have to cover it completely, just hover your hand over it. Does it make a sound, right? So it might start out with like a really pitchy noise, and then, you know, it would change, right? Based on if you put your hand over it or not. Okay, so it should be like a little theremin. Okay, let's take a few minutes to do that. If you're still trying to find your equipment, go ahead and look through your boxes. I'm going to use the large one this time. And on the buzzer, remember that the red side is your positive, and that is your longer buddy, the longer leg. Maybe we should use this. And so if it doesn't work, then just check your connection.
Where would we connect the piezo, since on the diagram it's like the two lines right next to each other, but the piezo is like 4 apart, I
Yeah,
think?
that's fine. You can, because it's the larger buzzer. So you just make sure that you have the positive and the negative distinguished. Um, yeah. So I connected mine just like how they had it, but it's just gonna take a little bit more room. You don't have a lot of components on this one. So if you want to, you can put your photocell a little bit further down. And then make sure we line up the leg, okay? As long as they line up the leg, like how you see with the green dots, we're okay. And then for us, when you're looking at your resistors, I put the link to the resistor color code here. You can use this one, or you can go to the other one. Okay. So we need to have the 10K. Okay, so it should show like the brown. Okay. And then, so there should be 4 lines instead of 3. Any other questions?
Sorry, one more about the piezo. Which leg goes to which color?
The longer leg is the positive. I know it's hard to distinguish on the fat buzzer like that one. And they don't put a sticker on it, but yeah, there's one leg that's slightly longer that will go to the red. I think this is the 10K. I hate it when they don't label these.
If you turn the piezo upside down, you can see the plus and the negative
Yeah,
underneath
on the
it.
bottom, usually they have it labeled too. Thank you for that. Let me pull this diagram. So as we look at this picture, you would see that it is it is analog because so we're gonna hook it onto the A0, okay? Compared to what we've been doing with the digital on the LEDs. And then for your speaker, since it's digital, you can then hook it up with the anybody finish?
I have a question.
Yes.
So the resistor that's used for the analog wire that connects to the photocell, um, why isn't that used like directly between the photocell and the wire? Why does that go to the negative side?
Yeah, because it's going to the analog, and analog is variance as it is wave, right? So you want it to, so the point is that if it's dark, it's going to change the pitch and the noise. And if it's light, right, it would increase or, change the pitch again. So it's either decreasing or increasing. So what you want is you want the resistance combined from your photocell with your regular resistor to be within the LDR range, which is 20K. So when it goes between the wire before it goes there, before it goes into, because you transmitting from signal from your Arduino, right, to the board. So what you want to do is you want to regulate both sides. I don't know if that makes sense to you, but okay. So here, this path, right? So this is gonna be, we wanted to send it from the analog over here. And from this, we are actually connecting into to the ground side. This is the negative aisles right here.
Yeah.
Okay. So as it flows from positive to negative, you want to regulate, you want to reduce that too, and
Yeah.
exit
But
it
then
out from the negative side.
why wouldn't the lead be the lead of the connector? I mean, the lead of the resistor, at least one of them, be between the photocell and the wire? Why is it like after both of them?
It's not, it's in between. So you have from positive, this is positive going into negative, and this is on the positive side.
Were you meaning the other side?
So are you saying that if it should be like the wire behind this? If the wire is behind this, it's only going to be working with this only. So you can't have it because this is on the positive side going into the negative side. So you have to have it in between those two.
Okay. Because it just, like, it doesn't look like it's in between the wires. It looks like Because like the order of the connections is like photocell, the wire, and then the resistor.
Yes.
And I'm sorry that I'm asking it again, but so why? Since we want to reduce the energy that's being sent from the photocell into the wire, then wouldn't we put the resistor in between that, or why wouldn't we do that?
Oh, so you mean put the wire behind this right here?
So like one lead goes into the negative side for sure for grounding, but then the other side, instead of going like to the left of the wire, shouldn't it go on the right of the wire?
So
Right?
this is a 10K, right?
Yeah.
This is a 10K, and this could range a lot higher than 10K.
Yeah.
It could be another 10K. So let's say that this is a 10K and this is a 10K. This could be like 25K. So if you put it behind that, combined, it will be a total of 20 plus K. But if so, you going from a 10K, right, to a 10K and then exit. Because if you don't put the resistance here, possibly that you're going to have a lot higher K ohm coming from this. You know what I mean?
Yeah. I know that the resistor reduces the power because you don't want to like overload the analog.
Right.
thing. Um,
But if you put if you put the wire behind this resistor, the photocell, right? When it goes to the negative side, it's still going to be at 20K.
oh. Wait.
So you want to keep that path at 10K regulated. Right? Here at this point, it's going to be 20. So as it exits, it's going to reduce.
Oh, okay. I think I see now.
Because this is variance, because it's really depends on how much light you have in the room.
Right.
So if you have like all your lights turn on, or if you actually step outside on a bright sunny day and you bring the circuit outside, it's going to be higher on this side. And then when it goes over here to the negative side, you want the 10K to be here, because if you put it behind those two, when it goes, that means that it actually is less coming in and then it's more here and then it exits. So because it's a full circular path with the circuit, right?
That's right. Yeah, I did just remember that. It's a full circuit. It returns. All right. Yeah, that makes sense. Thank you.
Yeah, no problem. Well, I'm glad Dr. B or whoever taught you guys physics is sticking. Because I know that for community college like MVC, you only getting this at or in physics courses. But I really think for engineer and this is why university have a lot of you are computer science, or you are going to be in computer science, right? You will have to take a digital course, and so they'll go over the concept again with electronics. And then for the engineer students, especially electrical engineer and computer engineer students, they have to take additional electronic courses.
Yeah, that makes sense.
Yeah, because this is what we do, right?
Yeah, that's right. I mean, there's definitely like with the electrical engineering, there's definitely like coding and then understanding how the electrical currents
Yeah,
work.
I have a few family members who are electrical engineers. They work more with circuit boards and stuff, but they don't
Yeah.
do programming. The programming side is the computer engineer. So if you want to go into the engineering courses, right, and then you have to take engineering math with it too. So anybody got results yet?
Yeah, I got mine working.
Good. It sounds loud.
Yeah, I unplugged the piezo because it just, I don't
Yeah.
know if you guys can hear
So
it.
yeah, that you guys hear that? So it's gonna be very high pitch. So if be ready. Okay. All right. So since we're working on that, all right, let's take a few more minutes to finish that up. and then we'll talk about the code. Yeah, check your COM and check your board information. Yeah, when you unplug your Arduino, sometime it reassigned the COM port. It's always good to disconnect the power before you start playing with power. So even though at the smallest level, right, you don't want to get shocked or get hurt. Let me get the lights on. Any questions?
Professor, I think
Yeah.
there's a question in the chat about the pin 13, and I was wondering about that too.
Pin 13.
Yeah, in the program it says for, all the way in the top, I guess, where it says the constant int LED pin equals 13, but it looks like we're not even using that.
Yeah, it's not even used, so probably an error. Yeah, so this was supposed to hook up to an LED. So you
okay.
can comment that out, or you can hook up an LED to it.
Okay, nice.
Yeah. You can comment that out. If you want to, you can hook up the LED. On the next one, you would see an LED. Okay. So when you're working with sensor like this one, it's always good to have the calibration value. As you can see here, so we declare a variable at the top, sensor value. And this is gonna hold what is received from the photocell. Okay. Now on the sensor load, this is a calibration value. So you want to have, and you know, for the small, the CDS, this is the norm for it. But when you work with other type of photocell, especially if you're looking at like solar panels and stuff, they use different solar cell, right? Then it can go a lot higher than this. So keep in mind that this might not be exactly the same for other form of photocell. So for our small little photoresistor, this would be your start. Then your high value would be 0. So when for the high, that will be 0, and for the low, that will be 1023. So what does this really mean? If you come back to what we talked about earlier, how it's sensing light, right? So when there's high amount of light or a lot of light, then you would have a higher lux. So that will be the first variable. The second variable, if you're looking at the low, right, we talked about like a really dark hallway, then it will be 0.1. Okay, so with that, sorry for scrolling down right now. This is what you need to give it for the low, and then this is what you need to give it for the high. And then it's good that you point out we didn't connect to LED pin, but you can put an LED to it. Just, move it into a different area and you can connect it. In the void setup, we establish, you can also comment this out if you don't have an LED pin, right? And comment this out if you don't have an LED pin.
Excuse me, Professor.
Yeah.
I have a question. Is it supposed to make this noise?
Yes. Yep. When you put your hand over it, it changes, and when you don't put your hand over it, it changes, right?
Well, it kind of mutes it if I have my finger over it.
Uh-huh. So sometimes you get like it depends on the buzzer. If you use this little small buzzer, like I have, you hit wee, wee, and then sometimes if on other buzzer you would hear something like that, little staticky and change. Uh-huh.
Thank you.
You're welcome. All right, Alex, I see your message. Okay. Global variable use. Okay. Yeah, it looks like it's it looks like it's using COM4. Okay, let me stop share real quick. Let me enable share real quick. Can you show me your error? Look at David go. Alex, can you share your screen real quick? Let me see. I know, Mom.
Sorry, it's just because I have I'm using two devices for this.
Oh, okay. Yeah, it looks like make sure that you check your COM4 on your port side. If not, you need to unplug your Arduino, or press the reset button. Press the reset button. Maybe tap it twice, and then unplug it, and then plug it back in. Okay. If you finish this, one, you can work on the next one. If I can always add another project to do tomorrow, a short one anyway.
I have a question.
Okay. Yeah.
Oh, unless someone else had a question.
Go ahead, Ryan.
Okay. So the wire that's plugged into power and it goes into the positives. Hold on a second, please. Okay, so the wire that's plugged into the power pin from the Arduino that goes into the positive side on the breadboard. Why does it go into the positive side?
Are you wait, for which component?
For the so wait, sorry, one more moment.
Okay, so so you have the ground. Let me share screen. You're referring to this one, right? Not the next one. Okay, so
Yeah.
on
Okay,
on
so
the is this the one that you're referring to?
yeah,
Or
yeah. So
okay,
the
so
one that's
what you
plugged in the
do,
power.
yeah, so you can actually take this wire and then plug it next to plug it from here to there. What were you doing is you're bridging the channel, right? So what it's gonna do is the flow is gonna be here to here, and it's gonna pick it up and it's gonna send it here.
Oh,
You see how the
wow.
bridge is?
They can do.
Yeah, this is why you don't overlap on the rows and the columns on the
Oh,
breadboard, because when you and when you're looking at the ground is going to go from this black leg to the blue, and then it's going to connect to this blue because it's going to flow, right? And then it's going to flow to here,
oh, wow. That
okay,
makes a
on the
lot more
negative
sense.
side. And
Okay.
then, so in the last few diagrams, we started doing that, right? When you're bridging the across. So why are we doing that? Because if you're looking at the Arduino, there's only limited number of ground connection.
Yeah,
So if you have a bunch of components, you can't just connect like 5 of them onto one connection.
that's
You
true.
have to bridge it onto the breadboard. The
Okay.
same thing with the on the positive side, right? You have both positive sides. So I can have this connected to another pin. Sure, I can do that, or I can just have it getting to the one wire, because otherwise, you've seen projects where they have like 25 different wires for like
Oh,
4
yeah.
components.
Yeah.
It's because they don't use the preform wire accordingly. So by concept, it should be done that you can bridge it that way. Yeah, it's crazy
Okay.
thunder right now, sorry.
Yeah, yeah, definitely. We hear that over here too. So by plugging the pin into the ground, or not the ground, the 3.3 volts on the board,
Mhm.
putting onto the
Yeah,
breadboard, is that
you're
restricting?
distributing it. No, yeah, so when it gets to the, so from the 5 volts, this is the 5 volts, right? So from the 5 volt side, when it gets here, right, it's gonna go here, right? And then only because you can take this wire and connect it directly to here, sure,
Yeah.
but when it gets here, it's gonna go to this down here, and then to the resistor here, to your photocell.
Right. And
Okay,
so that's like restricting the flow of like restricting the amount of volts that's being passed from the photocell to the board, right?
right. So when it gets here, it's gonna itself is a resistor, so yeah, so it's gonna have resistance there anyway.
Okay. And
That's
then
correct. But
so I know I asked this before, but now I'm like really curious. So if we already have the 5 volts that's restricting the current from the photocell, then why are we also using the resistor? Isn't that like 2 times the power of resistance? Or
yeah, but you want it to be a 10K minimal. So here, but this one also you can pull up too. It doesn't mean that it's always going to pull down. So you're going to have, you're going to have, so it's going to flow here to here, and there's going to be resistance here, and that's going to be for the analog side, and also it's going to flow here. Okay. um Now, but you don't want too much of a resistance, too much of the resistant reducer sensor capability. But yet at the same time, going back to the table that we talked about, you need to be in that range. Okay.
okay.
So what I suggest that you can test your theory is to take out the 10K resistor and modify it with a different K resistor and see if it works. Okay, so like if I
Yeah,
go from 10K to 5K, is it better or lower? So you can have a sense of, is it more resistance or less resistance? So if we reduce resistance, there's more power flow. If we increase the resistance, there's less power flow, and you can see.
okay. And so
Okay.
then just to confirm, having having the 5 volt wire and the resistor, that's like double the resistance, right? Or like
The
more.
10K here, and for itself is another 10K.
Right. Okay.
Right.
Okay. I think
So
I can.
if you're looking at, if you, so the photocell, the resistance, it can go up to 600K. See?
Yeah.
So if you don't put another resistor there, you know that might be a problem. So um it depending on how light or dark of the environment you in. Okay, so if you're in a dark place, right, you want to consider the amount of the resistance
Oh
that
yeah.
you're giving it. But if you in a lighter place, you can reduce the resistance, and
Okay.
that's
Oh
the
yeah.
point that I
So
want to drive home.
does that also mean that, like, also in a dark room, you'd want to reduce the resistance? Like, you'd want to take off the resistor if ever.
Yeah, so in the dark room, you want it to be 20K. So if you turn off all your light, like at dark at night with no light, then yeah, so you want it to sense something. It's harder for it to really detect light at that, or actually easier for it to detect light when it's dark, right? But when you're in a light room, it's harder for it to detect light when there's already lights in the room.
Okay, that makes sense. Thank you. Guys, it's
Does
all
that
coming together now.
okay. Other questions? All right, let's touch on the code real quick. So we didn't have an LED on this one. You can also refer to the next one if you wanted to hook up the LED. Here we want to have a while loop, okay? And while loop, with the while loop in programming for C, it only exits when the condition is false. As long as it's less than 5 seconds, right? It's gonna take what's read from the analog pin, which is from your photocell, and store it into the sensor value. And then we also apply a conditional statement. The sensor value is, if the sensor value is greater than the sensor high, then we would have sensor high and a sensor value. So Alex, I forgot that you had an issue with your Arduino earlier. Did you figure it out?
It's still giving me the issue. I'm not exactly sure how to share the screen though, because it's, oh, okay. 1 second. So yeah, yeah, I'm not sure. I tried sending it again and I got this again.
Click on your tools and let me see your port.
When I sent it to Com3, it would say that they're like that they couldn't find the device.
Yeah, because it's not using COM3. I think it's using COM4. That's what it says on the error message.
Yeah.
So click on tools and then go to port.
Tools, port. I'm not sure if it's showing on your side.
No, I'm only seeing your original screen. So yeah, I see that you clicking on something there. Okay, click tools.
Because I'm looking at it from a different end and it's not showing the drop down, but I do have it on COM4 right now.
Okay. And you selected COM4, right?
Yeah, COM4 is selected. There's another one that says COM5. Should I try that one?
No, does it show Uno on COM4 or is it not showing on COM4?
Well, the board is Arduino Uno, and for port, there's one that the COM5 says Arduino Uno.
Yeah, so click COM5.
Okay.
Click the one that says Uno next to the COM. It takes
Currently compiling.
Okay, so it's saying the same thing. Verifying flash memory again.
Oh, it's making sound now. Okay, sorry, I'm really excited. I've been having trouble.
It works?
Yes,
All
thank
right.
you.
Yep. So Alex, I think that to reduce future issues with your COM, I think that you should, when you get a chance, are you using Windows PC?
I believe I am.
Yeah, so you need to talk to me a little bit close to the end of class. I'll help you fix the problem, okay?
Thank
Yeah,
you.
you're welcome. All right. Any other questions? Okay, so we were saying that it has an if statement. And so if it's low, that means if it's 0 for the sensor value, right? Then we are gonna have it turn off the LED at the end after the while loop. So for the loop here, it's gonna read your analog, and then the pitch is gonna be just gonna map whatever that it's received from 0 to high. From low to high, so from 1023 to 0, and then 50 and 4000. And then it's gonna play the tone. So the parameter that you have here under the tone, you're using the tone function. You are gonna bring down what you declare as the pitch here, and you want to specify the parameter 8 and 20. So now if you wanted to change this value, you can. That would adjust how it's gonna sound from the tone, okay? And then it's only gonna delay 10 milliseconds. So if you want it to wait a little longer, you can also change this value. So the whole point is you can also adapt LED to this, but we want to make sure that we implement how it's going to play the tone once it sends, light or not. Okay. So that's going to read from the analog side. That's what you plug in as A0. Okay. Questions? Okay, since we have time, I think we're gonna attempt the second one. And then tomorrow, I wanted to show you how to do maybe one really short exercise on another one. So next week, I plan to do a piano project, and also I have the touch sensor for the piano project. And then I also have proximity sensor and ultrasonic sensor that we will be using, and a motor. So I'm going to do a project that's going to be using to make those automated trash can. So for next week, if you have like a box, a small box, a shoe box, something like that, just save it for next week. And then I will have you customize your trash can. So that way you know how to make those expensive, the metal trash can that they sell that sends. So when you put your hand in front of it, it opens the lid. So we're going to do another project like that. And I've done it with, 12 to actually 10 to 13-year-old, and they made it work. So I'm sure that we're going to be able to make it work in a couple of days. Okay. All right. Any question with this? Okay. So once you're done, just take a picture of your circuit, and that's what you're going to be using to submit to the lab. Here I put a little bit more explanation of what it's supposed to be doing.
Yes.
Question? No question. Okay. Since you already have the board, you can also use it. You can add the LED to the existing one, or you can build another one. And on this one, when you put the finger over your LED, it's gonna stop working. Okay. And so on this one, again, we're gonna use the resistor, and we're gonna plug it into the A0. Okay, very similar to the last one. All we did was, and on the LED, you also need to add the resistor for the LED. And when you plug in the resistor for the LED, make sure that it's on the second column here, not the same row there. And the wiggly leg is the long leg. Okay. So it will look something like that. And from the last project over, you can just hook up the LED, put it onto the pin 13, uncommented some of the area in the code, and then that should be fine. Okay. Kevin asked for the code when declare the sensor pin. Do we put A0 or 0 like it's stated in the document? It will be A0 because A0 is the analog 0. It doesn't have just a 0. The 0 on the digital side, I think it's dedicated to the for the PWM on the 0 side, so you need to put A0, otherwise it's going to get confusing. So how can you use this project for the real world? How do you use your photo sensor for the real world? I see security light, those, you know, dawn to dark sensor light, or even like the light to your house for your porch light. That will be useful. Okay. Hallway lights, possibly for hospitals or facilities where they need to, it needs to sense. If you can think of other applications that will be useful. For the buzzer, right, that could be alarm system. A lot of the alarm system use laser sensor. Basically, it's gonna send, send the light, and then if there's an absent, if it doesn't receive the light signal, it will sound off. For the motion sensor, we would use a different sensor like that down the line, but you can adapt Photocell for, you know, if it's detecting any kind of motion, like small object at least anyway. Okay, so if there's an interrupt in the light, then it would sound off. Okay. And if you don't get to finish the second one today, that's okay. We can continue to work on it tomorrow. Questions? Okay. So going back to what Jose was asking, right? Can this be applied for a lot of the realistic things just outside of just light for homes? Sure, you can. What about for people with disability, like people who cannot see very clearly? You can have a buzzer, right? When they are, when, they put their hand over maybe the stove or something that will be hot. There are a lot of applications if you're looking at, things for, healthcare use and such. So we can think about how we can implement something like this for devices. Okay. Any questions? Any other questions? Okay, so the second project on this is gonna be very similar to that one, but on this one, we're declaring the pin for the LED. We're declaring the pin for the sensor. Okay. Now, oh, Kevin earlier for the code, when you ask for the constant sensor pin is 0, if you add the A, it's gonna throw an error. Okay, because this is a const. And then for your light and your light value, so we're gonna have a variable that's gonna store what's being registered by our photocell. And then, so that's gonna be your light cal, the first variable. And it's gonna receive, right, from the sensor pin, and it's gonna do an analog read. And then for the light valve, we wanted to make sure that it's also, for the loop, it's gonna continue to receive the signal from the sensor pin, and then it's gonna convert that as an analog signal and store that into light valve. Okay. So if you want to jazz up this program, you can add in the serial monitor with the 9600 baud and then do serial monitor print line like what we did yesterday. So whenever it sends light and it stops sensing light, it will tell you the actual value. You just got to make sure that you pass the variable inside the print line parameter. Okay? Kind of like what we did yesterday. So if you really wanted to see the actual value that it's sensing, use the serial monitor, but you have to include that here. Okay. Like I would put in this, serial monitor 9600 for the baud, and then have it output doing serial monitor print line. And then instead of the baud, we would then print the value light valve, pass that into the parameter as it loops. So when it continues to sense light, it's gonna then be able to show you the actual value so you can see, and then open it up and so you can actually see what it sends. Okay, so you can try that. A lot of people, they do this project, so you can also find, YouTube video, or you can make a little tutorial and teach other people how to do this by putting up a video there. Any question? Okay, good. You got things working. So in your Arduino book, there's also another project with the buzzer, but it uses multiple buttons. I think you should have like 3 or 4 buttons in the bag that it gives it. That's project 7. That's on page 80. If you have some time, you can play with that. You can also do like the hourglass. There are a lot of different type of projects that you can also make out of your kit that you have. Okay. So we are going to move over to toggle base type of switch or button in the future. Let me see if they give you a motor. Did everybody receive a servo motor? Do you know what the servo motor looks like? It looks like it has like a white blade with the blue body and a couple of wires attached to it.
Is it this one?
Because I'm not sure that they give you that. Yeah, like that. Very good. Thank you. Okay, you guys received that, right? Okay, so you're gonna need this, okay, for our next class. I'm gonna have you do, we're gonna still use the next few classes, we are gonna use this. So in order to be successful with the trash can, I think they only gave you one of these. So we'll do the lid with this, which is gonna be, you know, it depends on how big of a box you're using. It might be a little weak, but it will work. So the motor, all it does is gonna flip it open and close. And then I've also used this with like with photocells to really sense. So when you shine a light on it, it rotates. Kind of like, you know, like a sunflower, it would rotate wherever the light is at. So I'll include a couple projects like this. Good. All right. Just want to make sure that you have that. Thank you for sharing your circuit there. It looks great. Okay. So did you test your light to see? Oh, good. Cool. You can also make it where, yeah, so it's completely off and then you can put it on. Very cool. Oh, see that? Thank you.
I don't know, it has some faulty wires, or sometimes it turns off and sometimes it stays on. Or
Yeah, it's because of all the extra light you have in the room.
oh, okay.
Yeah, that's why it's like that. But you test it, you know, in the dark or outside of the range that you give it. Yeah, it should work a little better. So I think we probably should check the calibration value on that. Okay. Yeah, it needs to be calibrated. But yeah, it looks like it mostly working. There you go. Yeah. Yeah. It works way better when it's like dark in the ambience light area or your environment is dark.
I have a question.
Sure. Ryan?
Yeah, we can calculate the amount of resistance we need for certain connections, right?
Yes.
What's the formula for that?
I'm sorry, I don't know the formula, to be honest. I haven't touched electronics side of the house for a while now, but I can provide that for you in the next one. So I think it gives you the VCC information in the earlier part. Let me see here. I think in the first exercise, it talks about the VCC, but I don't have the formula included.
All right.
Because I don't intend for this class to be super electronic based. It's really just to give you enough so that way you can program it.
Yeah, that makes sense.
Yeah, I'm sorry. I'm also not an electronic engineer. I learned electronics, you know, pretty basic through college and things like that too.
Yeah.
And a lot of these things that I picked up is because I learned it.
Yeah, that
but
makes sense.
It's been 30 years since I took physics, so there you go.
Oh dang. It's like wow. So in that case, which resistor are we supposed to use for part D of today's projects?
You can use, oh, I forgot to include that, right? Yes, I did. You can use the 10K. I think it should be fine. Oh, for the LED? Or are you talking about the photocell?
The photocell.
Yeah, you can use the same one you used in the
Two.
last one.
Oh, what's the blue one?
The
10K.
blue one's this picture.
Okay.
So yeah, David showed earlier. So you can use for the LED, you can use the small one.
Okay. And for the photocell, uses 10K resistor?
Yep.
Okay, thank you.
You're welcome. Other questions? Okay, so next week for the piano project, if you have fruits at home, foil or Play-Doh, you can use either one of those. I mentioned before that fruits with acidic fruits like oranges, lemon, grapefruits works really well as conductive ends. So those are going to be our notes. Okay, so if you have lemon tree in the back, you can pick out 5 or 6, but I hate to say that we would waste it. So if you have kids at home that have Play-Doh, you can also use Play-Doh. It doesn't matter as long as you use something conductive, but not water, because I don't want you to get hurt. So and also if you have like foil, some foils work better than other, as you know, because the elements that they use, the ingredients that they use to make foil, sometimes it's not purely more conductive metal, but foil usually works okay. I mentioned that number 4, pencil also would be useful, but I don't need for you to go out and look for those type of pencil. It will be a waste of your money. So use what you can find at home that will be cool. We would, we would put it together, and you would use these wires, and all you have to do is poke the hole into the fruit and then be able to do that. I have tested with apples and oranges and lemons, and it works fine. Play-Doh worked really well. The little kids, they love that. Um, so you can also use Play-Doh for your project next week. Okay, so we'll do like maybe 3 big projects, because it takes a little bit of time to get some of those projects going. So just keep in mind, and then also save a small box. So if you receive packages, it doesn't need to be very big, like smaller than a shoe size, nothing way too heavy. So that way you can cut the top of the box or the side of the box to make it into like a lid. Or if you don't have a box, you can put together something using like thicker paper or something like that. Okay, so we'll do a simulated trash can so you have an idea of how to use motor to be able to drive and rotate and open things using Arduino. So once you have it working, you can house it inside a small container, and you can put it into your trash bin container, and that will be opening the lid. But with one servo motor, it's going to be pretty weak. So I normally would reinforce it with another one, or use some kind of spring. This is why you would see that they would have some kind of spring mechanism that's built into the trash can. Okay. Any question? Okay, I think I'll stick around for the next 30 minutes or so in case you have questions. I'm going to stop the recording in case the people who want to watch it later. And if you're done, you can type into the chat your name, and so I can add in an attendance.